So welcome to my presentation. I see the room is almost full. Thank you. I'm Vincent Latombe. I work as a software engineer in CloudBees. I'm a recent recruit. I've been a member of the Jenkins community since 2010. I started getting involved with the Jenkins folks, working on the ClickCase plugin, which I was using in my previous company. I did several contributions to the core, to the Git plugin, to the Literate plugin. I'm trying to get involved in as much as I can in the community. So today I will start to explain to you what is exactly this Literate plugin, because how many of you have already heard of this plugin before? Okay, so I see like 10 people. It's not much. That's kind of normal. This plugin hasn't been, let's say, properly released since it exists. So I try to explain to you what this plugin does. It's an interesting plugin. It introduced a lot of new concepts. You heard about the workflow, right? A lot of things which are now in the workflow, they basically were implemented in the Literate plugin in the first place, the multi-branch architecture. Many of the interesting stuff, putting things in the SCM, started from there. So it's kind of a nice thing to know where we come from and where we're going. Try to show you in practice what we can do this plugin, and talk to you about one deployment of Literate I did in my previous company, and then I'll go over into under the hood about the architecture of the plugin. So what's Literate exactly? So Literate refers to something called literate programming. You may have heard of this. It's been introduced by a guy named Donald Knuth in 1983. So Donald Knuth is also the person who created LaTeX. You may have known this or used that to write documentation, scientific documents. So the idea is to embed into text some programs that you can actually execute. So using snippets of macros to say, OK, when I'm writing this in the text, this is actually what has been to be executed. So the idea of the Literate builds is to apply this paradigm to builds, which means basically we describe using text what we want our build process to do. And then we use a special formalism markup to introduce, OK, this is a command that has to be executed. This is the kind of constraint I'm putting to my build. And then we can, using this mechanism, we can have both a README that explains to the user or the developer how to build the project, but this can be also applied for Jenkins to actually build the project and do the CI. So we basically use the SCM to store a file that describes how to build a project. So this is an example of what the project looks like. So you can see two interesting files in there. I mean, three of them. We have first this cloudbees.md, which is the default file that will indicate that this is a Literate project, that it used the Literate plugin to build. So by default, you can leave it empty. And then you can put in the readme.md the actual definition of the build. So I will show you a bit later what it looks like. And then we have this .jenkins folder that may help you to integrate with some of the Jenkins features. So first, a very quick cheat sheet about Markdown. I'm sure most of you already know Markdown, and it's always nice to have a refresher. So with Markdown, you basically can use text to do markup. So this is a section. A section is just a line of text followed by a line of equals. There are other ways to declare a section, but this is one of them. You can use basic text. You can put inline code between backticks, and this will be formatted as code. You can have a blank line followed by a line preceded by 4 spaces to have a block of code. So this will be rendered as a block of code with no formatting. So these are the basic construct that we use for the literate. So this is the most basic example you can find with this plugin, which is a Hello World Literate project, which contains one subsection called build. So what we do is the plugin actually look for a section that has this name, and then within this section, it will look for a block of code or any number of block of code, and then just execute them in sequence. So here, this will render as, okay, just one build step that is doing echo hello world. Can you keep your question for the end of the presentation? And then, yeah. We can, so this is really the basic stuff. We can now, okay, we have an echo, which is available on most platforms. You don't need any kind of tool to have this echo working. But in real life, you will need programs, you will need Java, you will need C++, Make, whatever. You may have a build that requires Windows or Linux. So you need a way to hint Jenkins that, okay, this build needs to be dispatched just like you would put an assign label in a freestyle job. Then here you can define an environment. So this is done using this environment section. So in Markdown, we use this formalism. So it's just a list of environment. So the list is described using this star. And then each component of the environment is between backticks. So here we have one environment which is requiring both Ant and Java with the version 1.8 and 1.7. And then in the build section, we are using this Ant command. And what it does is basically it will load the tool installation. So for the environment, we can use either labels or name of tool installation. And what it does is it's just loading this installation and make them available in the path. And for Java, it will add the Java home correctly as well. So if you use Maven or any other tool that is relying on this mechanism, that will work as well. So then in the build section, you just need to call the tool that you have dependent in the environment, and that will work magically. There is some kind of support of matrix projects. So we can use several environments. So this is an example with two of them. On Linux, we're using GCC, we're using Java 1.7, Ant 1.8. And on Windows, it's almost the same, except we are depending on Visual Studio. We can also have different commands depending on the environment. So by default, we'll try to match the closest command for this environment. So here we have one command that applies on GCC 4.2, which is configure make, and another one that applies to Visual Studio, which will be coding a batch file to build a project in this condition. We can also add additional tasks within the README or the marker file. These are features which we can control from the job configuration. I will show you in the demo just after that. There is support for what we call lightweight promotion. So lightweight promotion is let's say the fact that, okay, once you've done your first build, you may want to require someone to approve and load it on a test environment. Let's say you build your war, you archive the war, you make it available, and then you come in and then just click on the button to promote and load it to somewhere else. There is also support for self-promotion, which is basically the same, except the approval is automatic. So if you want to say, I have a first build, and then I will do, let's say, integration test, then I have a first build that gives me the status of the unit test, the quality analysis. And then once this is done, and only when this is done, the integration tests are launched and are executed as part of a subsequent task. We can also define additional steps in the job configuration itself, so not in the SCM. So this is usually a split between what you would like as a Jenkins admin the job to do, and the steps that the project owner will define within the SCM that you leave him the control. So for instance, at a Jenkins admin, typically, I will always want to have the timestamp enabled on the logs. I don't want the project to have to enable that by hand every time. I want to have a policy to discard the old builds because I need housekeeping on my servers to avoid my disk being full. I want to clean up the workspace before the build because this ensures that the build can be reproduced. And I want to handle the notification to whatever collaborative system I'm using, whether it's GitHub, Stash, Gerrit, whatever. So this use a system called branch property, which I will describe a bit later. Second kind of things that you want to configure, this time within the SCM itself, next to the README, will be all the publishers, when you have test results that you want to display as a Jenkins report. We are driving everything. We are driving most of the operation directly from SCM. So instead of having to configure a publisher in the job configuration, you will configure it from a file that is present in the SCM directly. So we have basically two ways to do this. There is the most generic one, which is a file that you put in the .jenkins folder, which will be named after the publisher, the class of the publisher itself, and contains just a configuration snippet. For instance, you could have, I don't know, publish, send a mail. Then you can just put the snippet for the mail publisher in this file. If the plugin has implemented this extension point, which is called agent, you can, instead of having the configuration snippet, which makes your build very dependent on the Jenkins class names and structures, you can implement this agent, and you basically have a DSL. So instead, for instance, for mail notifications, the basic form you would require an XML snippet. So its structure, what do you need to configure when you send mails? You need to configure to whom you're sending these mails, and maybe these options like unstable build, etc. So what you need in the end is just a simple text file that contains the list of people that needs to be notified. But unfortunately, that requires additional code because you need to specify, what you will map from this DSL to the actual publisher. So that's the kind of the same difficulty as what has been faced in the beginning in the workflow plugin. Basically, we are introducing new concepts, and most of the plugins that already exist in the ecosystem, they have been built for mostly one kind of project in Jenkins, which is the freestyle, and they require some adaptation or wrapping to be able to work in a wider context. So that's one of the issues with these new plugins, which introduce new concepts. There is a cost associated with the deployment. So let me show you what Literate does in practice. So I've included this slide, so I will publish my slides later on if you want to try it out later. So the plugin itself, it's available publicly. You don't need to build it. The only constraint is that it has never been released as a 1.0 or something. It's been released as a beta. And in the Jenkins ecosystem, you can release plugins as beta. The only difference is that they won't show up in the main update center. They will only show up in this experimental update center. So this can be used as a mechanism for developers on plugins to basically publish a version which is to be tested, to be battle tested, then send out a notification on the mailing list for adventurous users who want to try them out and provide feedback. And then once we got things stabilized and validated, then we can release a release. So basically, I will go to my local Jenkins instance where I have already this plugin installed. Let me switch to this mirror mode. Okay, so is this big enough? Yeah. Okay, so so I have this job which I will detail just after. For now, so the plugin is installed and it's adding this new kind of item which is called Literate style multi-branch project, which is kind of an overcomplicated way to say, okay, it's just a project that applies to your repository. We don't care about the branch, the particular branch you're working on. The fact that we're using a file which is checked in the SCM will be enough for us to say, okay, Do we have this file? Yes, then use it to build. If we don't have it, we just don't care about the branch. So let's go to this project. So this is really, it's not a very fancy project. It's just to show you the mechanics of the plugin. So each of these projects here are actually branches on my GitHub project. And there is this new mechanism which is called branch indexing, which is coming from the Multibranch plugin. So you will see if you go to the Justice demo this afternoon at 1 p.m., there will be a demo of the workflow Multibranch. It uses a similar system. Basically, it replaces the usual polling by polling the whole repository and just scanning branches one by one to say, OK, does this branch has changes? Does this branch contains the marker file, which I need to do my build? And if so, I just create the branch project and build this project. So let's start with a very, sorry, that's not the right example. So that's not the right example. So I'm back to this branch, which is called YAMMER. So I did not mention that in the first slides, but basically you can use different kinds of description language. So right now there are Markdown and YAMMER supported. There is an architecture to add a new parser if you want ASCII doc or any kind of other markup language that is more suitable for you. So basically in YAML, it's very similar to what you can find in Markdown. I have examples in both these languages. So here I'm just using a build, and this is the actual command I'm running. So if I want to check what it gives me in the actual job, so I can trigger it. I can also, if I do a change and do the branch indexing, that will trigger the build as well. So just to show you about how the build is structured, you have this branch build, which is created for each branch. And then under this branch, you have what we call the environment. If you don't specify any environment, you end up on the default environment, which is basically running on any node with no particular tool. So this is the basic structure. It's meant to be, it's the support for if you want several environments, then you don't need to change anything. Just add what is relevant in your descriptor. What this branch job does, it just clones the repository, checks out the branch that you want to build. Then it just, once it has parsed the descriptor, it just computes the environment it needs to build, and then execute the build per environment. So here I have only one of them, which is default. And then in default, I have the actual build, which is actually here, so which is my echo hello world. So it's just wrapping what I've put in my descriptor within a shell command, and then execute this, and I get my result. If I want several environments, so that's another branch, I think. Yeah, I have this YAMMER, multiple environment. Oh, sorry, forgot to check out. OK. So this is almost the same. So I have specified two environments here, which are Windows and Linux. And I'm using two different commands based on the OS I'm using. So if I come back here, OK, let me try something to show you that this polling thing is working. So let me OK. OK, so I'm checking some changes. I'm pushing back to the GitHub repo. So here I don't have the GitHub hook, so I'll just trigger the polling immediately so that you don't have to wait 1 minute to have the polling working. So the branch indexing, I can check the logs here just to show you what it looks like. So what it does, it just looking the repository and it lists the remote branches. For each branches, it's checking if the branch is there. Then it's checking if the file is there. So here I have two implementations available. I have the Markdown and the YAMMER. I'm using the YAMMER. So here I I have the Markdown that complains that the file in Markdown could not be found, but then I have these other lines which basically says, okay, another parser picked up, which is the YAMMER in our case, and then it selected the branch. And it does this for any branch, and then in the end it just say, okay, I have matched this branch, and I have found a new commit on it, so it just triggered the build for this branch. So here it has happened already. So it's the same as before, except now we have two environments. We have Linux and Windows. So just for the example, on my machine, I've created two slaves, Linux and Windows, and one has the label Linux, and obviously the other one has the label Windows. I can use labels, I can use node names. It just behaves the same as you would with the assign labels, except that on top of that, you can specify tool names. So let's come back to the build, just to show you that it has taken my change into account. And here, yeah, this is the thing I actually checked in just before. So can show you very quickly the same example with the Markdown. So this is the same project with the Markdown version, which is, I have this cloudbase.md, which I left empty. If it's not empty, this file will actively be used for the build. I can also customize either in the job or globally the name of the descriptor. So for instance, in the deployment I did in my previous company, we used .sf.yammer, which for other reasons. In the README, I had just this sample that you saw in the previous slides, which is basically the same as the YAMMER file. And then here, the build, it behaves pretty much the same. Yeah. I can, if I check out the actual build configuration, the job configuration, I have the usual name and stuff. I have a section which is called branch sources, which replaces the usual SCM section that you have in Freestyle, Matrix, Maven jobs. So what it does is it basically is the same information, except that you provide the full repository information instead of having to define one particular branch. So you need to have a SCM implementation that is able to understand that it's working not only within one branch, but with a full repository. So here I'm working on GitHub, and that's it. I have no branch to specify. Optionally, I can specify some include and exclude patterns. So by default, it just picks up all the branches. And then I have this section which is containing the branch properties I mentioned a bit before. So basically, this is a configuration that you can set in the job that will apply to one or all the branches. So depending on what you define here, you can say all the branches, they have the same behavior, or you can say that some branches, they get a different behavior. For instance, you're running your project, you have a master branch, you do your releasing from the master branch, you want to have a step which is called release in your readme.md, then you want this step to be available only on this master branch. It doesn't make sense to make it available in the feature branch. So I can use this to actually control in a finer grain what I want as an extra behavior. So here I've set up already a few examples. So there is support for parameters, for instance. So I have this branch which is Markdown with parameter, where I have a name parameter, which I can use. I have this other branch which is Markdown with promotion, which illustrates the promotion processes I talked to you before. So here it's a manual promotion. So yeah, the UI is a bit rough here. As I said, it's a beta. It's not something that's been battle tested by thousands of users. So yeah, basically I can just, so here it's just the promotion. I have, let's say I want to do a releasing step. Usually I would just build my project using CI. I would archive the resulting file, and then in the release process, I'd like maybe to tie my repository, maybe deploy this file to an external repository or deploy it to a Tomcat, depending on what I want to do. So basically what I will need to do is, in this promotion step, to basically access one of the artifacts I generated in the previous job. So I can do this using these setup steps, which is restore archived file. So it's similar to what you can find with the copy artifacts from other projects, except here it refers to basically the previous step of the literate job. And yeah, and that's pretty much it. So to show you what it looks like, so here I have this. If you know the promotion plugin, it's really look-alike. So I have this job, this build that has already happened. I have promotion status here, which allows me to trigger any kind of promotion. And here I already executed it once, but basically I can execute it once again. And if I take a look in the workspace to show you how it's set up, so I have this build section, which you know, and then I have this other section, which is promotion, which I define in the job configuration, and it's use the same system, so you can just define the same formalism. It's just a different section name. So yeah, it really, already allows you to do a lot of things. And to end this demo, I have another sample project, which is using just a Maven project generated from the architect plugin. So just to show you how it works, the actual YAMMER file that contains the description. So I have these two environments with the two combinations of Java 1.8 Maven 3.3, Java 1.7 Maven 3.05. And then I'm just executing the same command in both. So this is the perfect example of using a matrix build. And I have these two environments which show me that they picked up the right version of Maven and Java. So yeah, sorry, I'm going a bit fast here. Yeah, here. So I know that, OK, I'm running Maven 3.3, Java 1.8, and if I go to the other environment, I will get the relevant environment as well. So yeah, that's pretty much it with the demo. Now I'd like to talk you, so I come back to the, OK, I'll come back to the presentation. So I will talk to you about a real-life deployment I did in my previous company, which was, so just to give you the context, 3,000 developers with different divisions with historical backgrounds. So some of us were working in Java, some others were working on C++ backends. And on top of that, for the tooling stuff, we were using scripting languages, so Python, Ruby, Perl. So we ended up with, let's say, two companies in one. And they got merged with a common transversal department that was taking care of all the build and releasing environment. So our idea was to deploy a new platform for people to collaborate. That was so we selected the Atlassian Stash solution. And then we wanted to have a solution where basically they could basically just enter into the system and do the biggest amount of things by themselves, without necessarily knowing all the details of the Jenkins, even if that was the CI solution we were using under the hood. We had experience with Jenkins, so I was working in the Java division, and we had set up this fully locked down Jenkins instance where basically we were the only team who could create jobs. I think the maximum amount of delegation we would do would be to allow the integration team to schedule builds, but that was it. I mean, the other developers, they could just read the logs and diagnose the build failure, but they could not launch anything. So it was, basically the team was a big bottleneck, and we worked a lot on automation, but it still was a kind of a problem because it means that people, they were not owning their build process, they were just depending on us. On the C++ backend side, it was completely the opposite. All the teams, they had their own Jenkins, unsecured, with like 3 jobs on each one. They were like on a random server somewhere, not maintained, not operated in proper way. So it was a mess. So we tried to find a balanced solution. So our idea was to set up let's say a shared environment, but with enough liberty for people to build the project they want, the way they want it, while following some rules. Like we provide the environments, we know that, okay, for C++, we're using this VM image. For Java, we are the reference version. We have 2 or 3 of them. You can pick the one you want. You can migrate at your own rhythm, but you have to fit the environment. So we first acquired at the beginning, that was the cloud-based solution with the template plugin. Don't know if some of you know about it. And then we thought about this, and then we just found, I mean, that was about the time where the Literate plugin was announced by Stephen Connolly, one of my colleagues. And that was perfectly the solution that we were waiting for. I mean, we were discussing internally. We were seeing solutions like Travis CI that were only on the cloud, and for open source project, you had no control on your hardware. And we had Windows, we had so many different environments that we needed something on premises, and we were already used to Jenkins, so we didn't want to lose all these features, all this integration with the existing tooling that we have. So this is how the solution we've set up works. We have the Stash instance on one side, the Jenkins instance on one side. So for the deployment, we started with one master that grew quickly. We would have liked to have Tiger by that time to help splitting our master into several ones, but we didn't have this. In Stash, you have, it's very, I mean, if you don't know it, it's just like GitHub. There is a slightly different vocabulary. It's on premises, but it really works the same. You have projects which match GitHub organization. In this project, you have repositories, and then each user has a profile and can fork repositories and work and do pull requests, and you have this review, and etc. So we set up a plugin for Stash. So the nice thing about this is also it's Java-based. You can build plugins. It's just, I mean, it's not like Jenkins because it's not open source, but it's very easy to extend. So we set up just this panel where you can checkbox, say, okay, I want the CI on my project. And this, in the background, creates a Literate project with an existing template that we define with all our branch properties that define all the common behavior, like what I said, discard all bits, timestamps, publishing back to Stash, etc. And then this Literate just indexes the repository that people have. I mean, basically, they just added the descriptor. So we added our whole of documentation for all the features that we added on top of this. And then it does the things I showed you in the demo. So you have the branches indexed. Each project for each branch is created. It passes the marker to check what environment are available, and it does the build. So basically, this was the new CI solution, and everyone. The really good thing about it is that the formalism that we used for the file within the SCM is completely independent from Jenkins. So if we want to upgrade one of the plugins, switch a plugin to another, even drop Jenkins to take another solution, I mean that the formalism would remain the same. And at the end, of course, we update the build status. So we use that both to build the branches, so the regular commit, and to build the pull request and provide the necessary feedback that you want on the pull request. Whether did you break the build or not, did you raise some violations, did you break Feinbergs, etc. In the context of the deployment, we contributed the YAMMER parser for the Literate plugin to the open source version. Basically, some of us in the company, we were finding that the Markdown is fine for documentation, but using it, I mean, I encountered several times the fact that to have a block of code, you need to have a blank line before. You need full space. You shouldn't use a tab, and often you just make mistakes, and you don't see your mistake until you realize that it's just a Markdown grammar, which is like it is. And what we needed is something that was a bit more data-oriented, like YAMMER. So yeah, I mean, the parser itself was quite easy to implement. There was an existing parser abstraction that was very easy to do. Just to give you, so I already showed that in the example, so we'll skip that. But basically, yeah, we thought the YAMMER was more readable, more compact. Then the last section of my presentation, it's about what we have under the hood, and I think this will be interesting for you because I really think the future lies with the workflow plugin, and I think this Literate plugin has participated a lot into the, let's say, the base design of some of the concepts in the workflow, having things in the SCM, multi-branch support, etc. So yeah, I think it's worth mentioning. So we have this Literate plugin at the top, that is the Jenkins integration. On the left, we have the API, which is not dependent on Jenkins, that just parses a description file into an object, which is a standard build model. And then on the other side, we have other Jenkins plugins, which provides, so the SCM API that provides the multi-branch support, and the branch API that provides additional features related to branch management, like discarding when a branch disappears, the project should disappear as well. You can also set like retaining all branches for some time if you want. So yeah, I'll just skip this because I'm late. Yeah, just the SCM API. So it introduced these new branch sources I showed you. So the current SCM which are supported are Git, Markup, and Subversion, I think. But basically, I mean, that's one thing I built in my previous company. Unfortunately, that was closed source. You can build branch sources for pull request. This is actually being done by Cloudbase for GitHub. That should be coming out soon. And we plan to add support for basically all the review systems, so like Gerrit, Bitbucket, Stash, in order for people to use collaborative tools to have this embedded. And I think that once this gets out, that will be really great news for everyone. So Dead Branch, I think I already talked about this. So once again, there is a demo 1 p.m. at the Ask the Expert booth. If you're interested in seeing the workflow multi-branch in action, just come and see Jesse doing his show. And yeah, I already talked about this, sorry. Yeah, what's next about the Literate plugin? So the one reason I presented this plugin is mostly because I think it's very important that it's just like when you're working with G2E or any kind of standard. I think it's very important that you're quite independent from the implementation, because it allows you to evolve more easily your system as you grow. And I think what's really great about the Literate is that it introduced this description file. Unfortunately, at the time it was released in beta, it was really missing this integration with other plugins. And this is not free, you need investment. And with a workflow plugin, this is being done by Cloudbase. So I really think workflow is the way to go. And I think it's possible to reuse the current formalism of Literate to actually generate a workflow, drive a workflow. So even if you have a Literate job, you can keep your file, and then once we have the kind of bridge with the workflow engine, then you just reuse that and drive a multi-branch workflow from that. So yeah, take out. I really would, if you don't redo this version, all your configuration, or Jenkins configuration to SCM, I think Literate is a quite good solution to do that. I think workflow is even better. And use the description markup ideally. And yeah, give it a try if you like this presentation, and just tell me what you think about it. And this will be quite useful for, I think, to drive the future evolution. And yeah, thank you for listening to me. I think I have 5 more minutes for questions if you want. And otherwise, you can just go and have lunch. Thanks.